Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over rational functions. We're going to be considering how to find the asymptotes, wholes, zeros, and graphs of rational functions in two main forms. All right, we're going to start by taking a look at the two forms and some important information about them. Then we use those forms and information to find the necessary components. So the first form that we're going to be looking at today is y equals a over x minus h plus k. Okay, I refer to this form as the transformational form of a rational function. Transformational form. Okay, so when you write the rational function in this form, it's easy to tell the transformation. That's why I refer to it with this title. Now, some pieces of information about this. Just looking at this form, you can easily tell what the horizontal asymptote is. The horizontal asymptote is the line y equals k. And the vertical asymptote is the vertical line x equals h. You can also determine the shifts, as indicated earlier about this telling the transformations on the parent rational function. If you have f of x plus or minus h, these involves shifts to the left or right. So you shift left for plus or right for minus. If you have f of x plus or minus k, this is a shift vertically. You're going to shift up for plus k or down for minus k. All right? Okay, the second form we are going to look at is the form where f of x is equal to n of x over d of x. I refer to this as the quotient form. Okay, you have a quotient of two polynomials, the numerator polynomial or function and the denominator polynomial or function. In this case, how do we find the horizontal and vertical asymptote? It's slightly different from the first form. For horizontal asymptote, there are three cases you have to look at. Okay, so let's write it down. Cases. In each case, we are going to be considering the degrees of the numerator and denominator polynomial. So, case number one, if the degree of the numerator polynomial, n of x, or let's just call it the numerator, is greater, the degree of the numerator is greater than the degree of the denominator. In this case, we have no horizontal asymptote. You could have an oblique asymptote, but you do not have a horizontal asymptote. Okay. The second case is when the degree of the denominator function or d of x is greater. If the degree of the denominator function is greater in this case, you have y equals 0 as your horizontal asymptote, always. Now, in the last case is when you have equal degrees. When you have equal degrees, in that case, you find your horizontal asymptote by dividing. You just divide leading terms or coefficients. I'm going to use terms. You get the same result. So divide leading terms in the numerator and the denominator, and that will give you the equation of the horizontal asymptote. All right, some other pieces of information. Vertical asymptote, how do you find that? The vertical asymptote, that is simply the zeros of the uncancelled denominator. All right, zeros of the uncancelled denominator. Another piece of information you need to know how to find is how to find the wholes. The wholes of a polynomial function in the quotient form can be determined by finding the zeros of the cancelled factor. Cancelled factors. Okay, you can have one or more factors. Just find the zeros of whichever factors are cancelable, basically factors that are common to the numerator and the denominator. Okay, lastly, the zeros or roots, or you could call them the x-intercepts. These can be found by finding the zeros of the uncancelled numerator. Okay? All right, so that's that. All right, let's take a look at the first example, example number 1. The task is to describe the shifts, find the asymptotes, and sketch. Okay, so let's say we have the following following rational function, y equals 3 over x plus 4 minus 2. Okay, all right. In this problem here, we can clearly see that we're dealing with a transformational form. The form y equals a over x minus h plus k. All right, so that's important information right there. So let's discuss the shifts first. All right, so the shifts in the direction of the x-axis, or the horizontal shifts, you look at h, you have minus h here, so we're basically going to be doing the opposite of this sign right here. So we are going to be shifting to the left. So this is a shift 4 units to the left because h is equal to negative. You have to be careful with the sign when you're dealing with your horizontal shifts. All right, how about vertical shifts? We're looking at k here. We have plus k, so we are not doing any opposites here, just go in the direction of the sign given. We have minus 2, so we have 2 units down. That's your vertical shift, and that is because k is equal to negative 2. All right, so your the new origin basically is going to be on negative 4, negative 2. Next piece of information, we have to find the asymptotes. Let's start with the horizontal asymptote. Okay, the horizontal asymptote, remember what we talked about earlier in the notes, can be determined by using the equation y equals k. In this problem, we can clearly see that k is equal to what? K is negative 2. We used that earlier here for the vertical shift, okay? So our horizontal asymptote is the equation with the line y equals negative 2, since that is the value of k. All right, let's move on to the vertical asymptote. So for the vertical asymptote, we also talked about this earlier. That can be determined by using the equation x equals h. And in this function provided, h is equal to the opposite of this right here. H is negative 4. Okay, negative 4, that's what h is. So that tells us the equation of the vertical asymptote, x equals negative 4. All right. All right, now let's go ahead and do a sketch of the function. I'm going to sketch it somewhere to the right. So when you are sketching a rational function of this nature, the first thing you want to do is you want to sketch the asymptotes, okay, because they're going to guide the construction of your graph. Okay, now where are our asymptotes located? Let me go ahead and label my axis y and x. I'm going to shift my x-axis, my y-axis to the left a little bit since my vertical asymptote is really negative. Shift that to the left a little bit. There. Okay. Now, x equals -4. That's our vertical asymptote. So what does a line x equals -4 look like? Is it a vertical or horizontal line? Well, the name tells you vertical asymptote, and do not forget, when you have x and a number by itself, you have an extreme slope, which is basically a vertical line. Okay, think about x for extreme. We're going to go -4 in the direction of the x. 1, 2, 3, 4. And you draw your vertical line there. You see the extreme slope. So that's our vertical asymptote. Now, next thing we want to find is our horizontal asymptote, which is y equals -2. So remember, your y line is horizontal. It's a zero slope. So we're going to go -2 in the direction of the y, 1, 2, and draw our horizontal asymptote. All right? Now, how do we draw the graph? The graph of a rational function of this form is a hyperbola. Okay? Now, since a is 3 in this problem, that simply means that we're going to be using the first and the third quadrants. Kind of. So a is 3. So let's assume this is 1, 2, 3. We're going to be placing our hyperbolic curves in this quadrant here. The first quadrant or upper right, and then the third quadrant or lower left. All right? So let's go ahead and do that. So we have just a sketch. Draw something like this. Let me draw it again. So you have your hyperbolic curve. You go really close to the asymptote without touching it, and you cut it like that. And then the same function over here, and then that pattern just continues forever. All right? So there basically goes your hyperbolic curve, the graphical representation of this function right here. And one thing just to note, a side point, you see this new origin right here is -4, -2, indicating the shifts that we talked about earlier. Now, how do you graph this with a graphing calculator? Let me go over that real quick. It's not very complicated to enter. You just need to be careful with your grouping process while you're entering it, okay? So you don't do any inappropriate grouping when you're entering this expression. So to graph this function, you press Y to access the graphing window, and we're going to enter 3 divided by, now this is where you want to be careful. You have a binomial in the denominator, so to communicate that accurately to the calculator, you have to use your grouping symbol. All right, so use parentheses x plus 4, which tells the calculator to group x plus 4 together underneath 3. If you do not use the parentheses, the calculator will read it as 3 divided by x and then plus 4, which is inaccurate. So make good use of your parentheses so that your entry is accurate. So you enter it like that, press graph, and there you have your graph, just like what we have there. You have our vertical asymptote at x equals -4, our horizontal asymptote at y equals -2. Okay, so that's that. All right, let's take a look at example number 2. The task is to find the asymptotes, wholes, and zeros of the given function. Let's say we have f of x equals 2x squared minus 2x minus 12 divided by 2x squared plus 5x plus 2. Okay? All right. We can clearly see that this form is in the quotient format. We have a polynomial on the top divided by a polynomial on the bottom. Let's start out by looking for the asymptotes. First up is the horizontal asymptote. Now, how do you find a horizontal asymptote, remember you look at the degree of the numerator and the degree of the denominator. Okay? In this case, the degree of the numerator is 2, and the degree of the denominator is 2 likewise. So let's write that down. Degree of the numerator is equal to 2, because that's the biggest exponent in the numerator. Okay? And then in the denominator, the degree is 2, that's the highest degree. So the degree of the denominator is 2. So what happens in this case? If the degrees are equal, you simply divide leading coefficients. All right, so let's write that note down. Equal degrees basically mean you divide leading terms. You can divide the leading terms or leading coefficients, you end up with the same answer. Okay, so in this case, the leading term in the numerator is the term with the biggest degree. So we have y equals 2x squared divided by the leading term in the denominator is the term with the biggest degree is 2x squared also. When you divide these two, x squared goes into x squared once, 2 goes into 2 once, and 2 goes into 2 once. This implies that your horizontal asymptote is the line y equals 1. Okay? So that's how you find the horizontal asymptote for a function in quotient form. Now let's take a look at the next asymptote, the vertical asymptote. For the vertical asymptote, all you're basically looking for are the zeros of the uncancelled denominator. Okay? Alright. Uncancelled denominator factors. Now, how do we know what cancels out and what's uncancelled in this polynomial function? To determine that, we have to basically factor out the numerator and the denominator polynomials, and then we can easily see what the common factors out, cancel them, extract the uncancelled ones in the denominator to find your vertical asymptote. Okay, so let's start with the numerator. Okay, we're going to factor the numerator. So your numerator function is 2x squared minus 2x minus 12. Anytime you're trying to factor a polynomial, first thing to ask yourself is there a greatest common factor? In this case, there clearly is. 2 is the greatest common factor here, so you factor out 2. Divide everything by 2, you're left with x squared minus x minus 6. Okay, now let's proceed with our factorization. We have a quadratic trinomial. So to factor that, we're going to use the x game, or the AC method. In this problem, AC is -6 and B is -1. Now, what two numbers multiply to give you -6 and add to give you -1? Answers are -3 and 2. Now, in this polynomial, this quadratic trinomial I have here, you want to note that A is equal to 1. Okay, whenever A is 1, we can jump from this x game to the factored state. Okay, you do not need to factor by grouping here, as we'll have to do in the next function. So we have 2 times x minus 3 times x plus 2. You simply extract these two numbers. Alright, so that is the factored form of our numerator polynomial. So we have 2 times x minus 3 times x plus 2. Okay, now let's shift our attention to the denominator polynomial. So what are we doing now? Our task is to factor. Okay, remember we are trying to see what is common in the numerator and the denominator, the common factors, so that we can cancel them out and see what's uncancelled in the denominator. Okay, now, first thing to do when factoring polynomials is you want to ask yourself, is there a greatest common factor to extract? And the answer is no. So we have to proceed with the factorization of this. Now, since this is a quadratic trinomial, we're going to be using the x game again. AC goes on top, B goes on the bottom. In this problem, AC is 4. That's AC, 2 times 2 is 4, and B is 5. Now, what two numbers work here? What two numbers multiply to give you 4 and add to give you 5? Answers are 1 and 4. Now, can I jump from this x game to the factored state? The answer is no. Well, why not? It's because A is not equal to 1. Okay, whenever you have a scenario where the leading coefficient is not 1, then you have to factor by grouping. So you just have to keep that in mind. Okay, so how do we do that? We take the original polynomial and replace the middle term with these two numbers we got from the x game. 1x plus 4x adds up to 5x, all right, plus 2. Now we're going to deviate down the center and factor by grouping, okay? From the first two terms, the greatest common factor is 2x, so we divide 2x and we're left with, actually the greatest common factor is just x. There's no 2. 2 doesn't go into 1, so it's x. Sorry about that. Take out x, and then we're left with 2x plus 1. And then in the second two terms to the right of our partition, the GCF is 2. Always bring down the middle sign. GCF is 2. We're left with 2x plus 1. Now this is where you pause and check. Make sure that the quantities in the parentheses are the same, and that's the case here, which is excellent. So we're going to factor out these two quantities, 2x plus 1 and 2x plus 1. Factor them out. Now when you factor out 2x plus 1, you are left with x plus 2. Alright, so you have x plus 2, and that's the factored state of the denominator polynomial. Alright, let's reinsert that into the problem. So we have 2x plus 1 times x plus 2. Now, what cancels out? X plus 2 cancels out. And now, the instructions earlier was to find the zeros of the uncancelled denominator factors. The denominator factor that is uncancelled is 2x plus 1. Set that equal to 0 to find the 0 of that. Now to solve this, you simply subtract 1 and divide by 2. Okay, so you have 2x equals negative 1, and then divide by 2. Final answer is x equals negative 1. That is your vertical asymptote. All right, let's just put the side note here, vertical asymptote. All right, next thing to find, let's go back up. We're to find the holes, okay? Let's go ahead and find that. Holes. Now, what's another word for holes? What are the holes of a rational function in quotient form? This is basically the zeros of the cancelled factors, okay, of the cancelled or reduced factors, cancelled factors. So what you do is look at this polynomial function. What factors got cancelled out? x plus 2. So what do you do with those? You just set it equal to 0 and find a 0. All right. How do we do that? We simply subtract 2 from both sides, and your final answer is x equals negative 2. That is your whole. We have only one whole in this polynomial, in this rational function. Okay? Now, last but not the least is the zeros. Another word for zeros is the roots, or you can also call it the x-intercepts. They all mean the same thing. So let's find the zeros or roots. Zeros or roots. Zeros or roots are basically the zeros of the what? Zeros of the uncancelled numerator. Okay, so whatever doesn't get cancelled out in the numerator, you find the zero of that, and that's your 0. All right, so let's take a look at the original function. What is uncancelled in the numerator? We have 2 and x minus 3. So let's extract that. 2 times x minus 3. 2 times x minus 3. What do we do with that? We set it equal to 0. Okay? Now, this is a question. How can we solve this equation? Now, since 2, we have a 2 right there, we can divide both sides by 2. Only because that's a number. Remember, never divide both sides of an equation by a variable. Okay? That will result in problems when finding the zeros. So divide by 2, and you have x minus 3 equals 0. And then to get x isolated, simply add 3 to both sides, and you have your final answer, x equals positive 3. That is the 0 of this rational function. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. If you have any questions about any of the material we covered in this presentation or in rational functions in general, just place your question in the comments section below, and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to other great math contents such as this. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.